All right, welcome in or welcome back, everyone. Jake Dunn here with CGF, one of the developers of the UpStream tool. And this is your next video in the how-to series of how to use UpStream. And the previous video was sort of a general overview of what's in the spreadsheet and documentation. This video is going to be a step-by-step walkthrough of how to do a soup to nuts LCA using an actual project. So let's go ahead and jump right into it, shall we? I'll go and share my screen. There we go. So here's the disclaimers tab of the spreadsheet. Just a quick reminder, if you have any questions, comments, pilot feedback, go ahead and email to this particular email. That's what we'll be monitoring for this pilot phase. And yeah, it'd be great to get people's opinions on if the tool is useful or any features you might like or any bugs that you find. So before we jump into this, let's go ahead and talk a little bit about our hypothetical project here, which is actually not that hypothetical. It's a real project under construction currently. It's the PA Living Building. It's PA is an engineering firm that we work with, an MEP firm, and they are developing their new offices downtown in this historic district. They're shooting for Living Building Challenge certification. And it's heavily mass timber. It's glulam beams and columns and a CLT hybrid floor with a topping slab. So it's a great candidate to understand, how low can you go with wood? How does that impact the overall whole building LCA? It's also really interesting sustainability-wise because it's aiming to be LBC. It's in a historic district, which makes it really challenging, and it's also developer-driven, so trying to make it pencil out as well. And if it works out, it'll be the first in Portland, first Living Building Challenge certified project, the largest mass timber LBC project in across the certification body as well, which will be fantastic. So the other great reason to use this is that our friends over at KPFF did a lot of early conceptual analysis, looking at different structural types. So we have really good baselining information as we get into adding in the more advanced wood analysis. So we'll be using some of these takeoffs or carbon numbers to plug into the sheet for comparative analyses. So to do that, let's jump right into the calc sheet. And because we scroll around quite a bit, in this process, one thing that I found is really nice is if we open up another window and kind of do them side by side, so you can kind of see the tabs update in real time, which can be nice. So let's see, we've got that there. We've got to zoom out a little bit on my surface. So that screen's not as big as I would like, but this should give us a good enough way to kind of take a look at how this is going to work. There we go. Okay. So quick reminder, green is user input, blue is calculated value. Fairly straightforward. Jumping right into step one, which is defining product information. Here's all the different kinds of products that we can simulate. CLT and glulam are the most built out. But there are industry-wide EPDs and different pathways for analysis for things, even like LVL, if you'd like to do that laminated veneer lumber. Right now, we're just going to stick with glulam for this example. The next question is about the net installed volume of the product. It allows us to choose the units of volume, which were in cubic feet from the KPFF analysis, and it allows us to input a volume here as well, and then we'll convert it to meters cubed, which is what a lot of the calculations are based on, either using volume or converting volume into kilograms based upon density or information of APD. Critical that this is the net installed volume, not the nominal, because a lot of the calculations, especially once we get into the forest factors, are converting back up to meters cubed of roundwood coming out of the forest. So this has to be the net installed volume that we're putting in here for the glulam. So here's that compared to a baseline case information. So it sort of asks us in step 2, do you want to include this? If you say yes, it'll kind of lead you through the next inputs. If you hit no, it should blank it out, which is nice. So let's go back to yes. And then the next one is inputting the total GWP for the baseline case. We know what that number is from our friends at KPFF. And then it asks you, for your wood scenario, enter the impacts for non-wood elements. So if you're doing a whole building LCA, this would be for anything that's not wood. If you're doing sort of a assembly analysis, this might be like the miscellaneous steel that's still included in the wood structure or the wood roof in that respect. or if you're doing a component by component analysis, beam versus beam, you may not need to put anything in here. This is designed to be a whole building LCA across all of the structure and envelopes. So we have that number here as well for all the non-wood elements. And that is that piece. Okay. So once we put that in, this will start to calculate as soon as we get into the actual LCA modules, which start in step 3, calculating modules A1 through A3, product stage. So it asks us, do you want to include this? Generally, that's a yes. And then we get to choose our type of EPD for analysis. Here we've got industry-wide EPDs. For the glue lens, we've also broken it down into the quorum regional LCAs that are kind of feeding up into that industry-wide. So in case you did want to look at like the difference in Southeast versus Pacific Northwest manufacturing, energy intensities, you can. Or in some of the other products, we also have supplier-specific EPD types that you'll see populate down there. For this example, we'll use the industry-wide EPD. We actually see that we have legacy EPDs from Tally in there, and then also the latest ones from American Wood Cancel. Let's stick with those, the 2020 version. And then we start to see now we have enough information to get some feedback. In this case, it's sort of cradle to gate directly from the EPD. We can use this number to put into the calculation. It starts to spit out nets and gives us some nice feedback on, well, how did you simulate that? What's the underlying data source? Because we start to splice things together, the further we go, or there are those options. And then this is that kind of comparison baseline scenario, right? This is our steel baseline. Here's our non-wood elements, and then this is the wood element. And then it starts to calculate what that particular savings is as well, too. So that's giving us some feedback. So this gives us right away that, like, without even including biogenic carbon or forestry factors, we're seeing roughly a 30% savings from just the fact that wood is less energy intensive to make than some of the steel components in the building. So that's great. And then we can also start to do some toggling here where we can include biogenic carbon and start to get that feedback right away. So we start to see this disaggregated in the main output of UpStream to where now all of the biogenic carbon that's in that product at the end of that cradle to gate phase is captured here. And now if you are including this, it's highly recommended to start to go into the end of life scenarios, because if we don't, you could be over predicting this if you're just saying this is the amount of biogenic carbon stored in the wood, not thinking about what happens at the end of life. But you have that option to stop here or continue to go on. Our recommendation, I'm going to add sort of some feedback too, is that you would definitely want to try to at least take a stab at the end of life if you're including biogenic carbon. Then hopefully future versions of the tool too will get into some of the more advanced ways to think about biogenic carbon on a temporal scale. But that is a subject for another video and another research project. So moving out from this, right? So we've got that feedback. Now we can get into some of the other modules like A4. So transportation, you can include this as well. This is using the Tally data. So it gives you the option to include just the default, what gets spit out of Tally. And then we start to see that populate both the quantity and then also the reference data, which is nice, Tally default distance and LCIs. We could also say no to this, in which case we could start to input, how much distance and by transportation type using those Tally factors disaggregated once again. And then similarly, since we're trying to be really clear about how we're splicing this data together, this table updates in terms of like now it's saying that you're using the custom input distance, and then it's still using a Tally as the underlying background data. So let's go and just turn this back for simplicity's sake and then move on to our next piece, which is where it starts to get interesting. Calculating modules C2 through 4. This is the end of life fossil and biogenic emissions, or biogenic and non-biogenic emissions, depending on how you want to talk about it. So let's go ahead and say yes to this. We'll turn it on. It asks us to select your data source, and it gives us a couple of different options here. We've got Tally with biogenic carbon. We've got an EPD version 1 and version 2, and then also custom. So it's showing only Tally with biogenic carbon because we toggled that on before, right? We can't not include biogenic carbon at this stage based upon some of the previous input. So, You also might be asking, well, what the heck do any of these particularly mean? And this is where the documentation comes in. So for this particular input, let's see if this works. If I copy this, I'm like, okay, what does this mean? We can go to our documentation, and then we can just search for that. And then it should take us right to, that particular input in that particular step. So this is step 5, calculating, module C2 through 4. We get that overview of what's going on. Then it walks us input by input. So we've turned it on as a yes, and now we're into the end of life data sources. And then here's all those options. So here's the first option that we see. Then it walks us through, what does this mean? What are some of those underlying background data sets that it's using? What is the conceptual philosophy behind what the EPD is defaulting to, which is sort of a biogenic carbon as a net neutral emission? What does that particularly mean? You can read about it here. And then also we've got the EPD version 2, which is, in the 2020 versions, they point to the addendum to come up with a end-of-life scenario. It includes 100% landfill as sort of here's an option to look at if you do want to try to predict long-term, carbon sequestration. It's generally not used as much, but it is outlined in the EPD. So we've included that as one of the pathways to model it upstream. We've seen other firms use that as well. And then we also have a tally with biogenic carbon. Then there's a tally without biogenic carbon if that shows up based upon your previous ones. But this gets into a lot of what is going on, behind the scenes and what those assumptions are for what you're actually modeling. So this is a really important piece. We tried to be very clear about like what are those inputs, so folks could go back to that and understand what they're simulating at this point, because it's a lot of drop downs and sort of choosing your own adventure as you go through this. And what's nice too is that you actually can get some real-time feedback on what these mean, right? So if we do the biogenic carbon net neutral, which basically says that as long as carbon stocks are stable or increasing in North American forests, anything that happens downstream is going to be neutralized by regrowth of the forest. So you could literally, chop the trees down, burn them, and then that would be counted as a net emission because they would regrow and that cycle would continue. You can read the documentation. This can be construed as sort of a overly conservative approach to it, but it is sort of the typical way that it's done currently. And now we're able to kind of see exactly where that carbon goes, and it starts to equal all of that out. So we're back to our roughly 30% savings. This has changed a little bit because now transportation is in there. If we look at the EPD version 2, right, this is looking at a long-term sequestration scenario, 100% landfill. It uses EPA warm, and it basically starts to account for the net sequestration or storage based upon the CO2 and methane emissions from doing a 100% landfill scenario. Doesn't include some of the other fossil emissions from like landfill equipment. So it's sort of a hybrid, cradle to grave in that respect, but it does start to take into account that those end of life dynamics, although it's quite favorable. So now when we include that, we see that our savings actually is really high, right? We're offsetting a lot of that other carbon from the structure, and we're at an 86% savings overall. This is probably as favorable as it gets. And if you read through the documentation, we sort of spell out, the decomposition rate assumptions and sort of like what's going on behind the scenes. But this could be considered to be a bit too favorable. And then we have tally, right, which then we start to see, they have their own sets of decomposition rates. They also pull in some of the non-biogenic emissions. And then in that documentation, it sort of like talks about what makes up all of this. But, we can toggle between these pretty quickly and start to understand the overall impact on the savings, which is really nice to combine these streams of data to get that particular feedback. So when we look at, tally, we've got 53% savings. So we go from like 27 to 53 to 86, right? Pretty wild variation. So definitely should be clear on, why you're choosing which one. And that's where the documentation hopefully helps as well. So let's stick with tally for now. It's sort of like the middle ground between those two. And now we start to see this get a little bit more populated. You can see that module D is not there, but if you go to module D, we're actually able to turn that on. And then we can start to see module D populate based on what we were selected before. Oh, I'm sorry. The other thing I wanted to mention, we'll get into this in the subsequent video, is what happens when you hit this custom button and why would you want to do that? But moving forward in this particular video, the next piece is forestry. We'll also cover that in a subsequent video. So I'm just going to turn that off and it will continue to not be calculated in this overall table. The other thing, the last step is looking at an uncertainty factor. So this was really born out of our EC3 kind of workflows. And when we were post-processing data, as we typically did, before we had UpStream, we would be getting data out of EC3 or other tools, adding in some of these other more advanced wood analyses to them. And then we would want to be able to compare that back up. So EC3 adds an uncertainty factor based upon whether you're using a supplier-specific EPD or an industry-wide EPD, and it takes a crack at trying to account for that uncertainty by penalizing kind of A1 through A3. So you're able to add one of those here if you wanted to be conservative, if you wanted to try to use your own kind of uncertainty factors, or if you're trying to marry these results up to EC3. You basically just put it in as percentage factor, and it sort of shows you what is going on and how that's sort of rippling through at least the A1 through A3 module. In this case, we'll just go ahead and delete that. We won't use it in this respect. But yeah, and like that's basically it, right? In terms of if you have the volume, you know what you're simulating, and then you sort of have a general idea of like what kind of end of life or LCA boundaries that you want to do. It's very fast to put this into the spreadsheet and get a variety of different data where you could start to do that sensitivity, or basically just stick with one, start to do other types of comparative analyses as well. So trying to give you, a good amount of granular data with a minimum amount of inputs was one of the goals. So we could start to do, more wood LCA faster and understanding, some of that inherent variability that's built within it. Like I said, the documentation is your best friend in this case to really understand what's going on behind this as we start to kind of pull apart these results and make it as clear as possible where they're coming from. Now you'll be able to go back and understand exactly, well, what does Tally model when it comes to a landfill versus incineration versus recycling split? And how do I feel about that, right, in terms of the specificity there? But yeah, I think that's it for this particular video. The next one like I said, we're going to get into the custom workflows and the forest factors. So just a quick reminder that, once you get into this and you have any questions, here's the email address that you can send that feedback to. And with that, I'll sign off for now, and hopefully we'll see you here at the next video. Thank you.